All right. Question 4 from Alex. Is it reasonable to worry about a super intelligent artificial intelligence causing the extinction of humanity, or is it another case of what Curt calls woo-woo?
Well, I consider it reasonable, so perhaps overstated, but I see as a far bigger worry driving demand for use of human brains down to nothing and effects thereof. To that point, I put sufficiently big tariffs on non-human labor.
Smart. Yeah, I think the way I put it in the Constitution is there is no value in replacing a human with a machine. It's sort of like, how do I do this? Curt, tell the story in your head before you start speaking it so you don't lose your train of thought. Um, so if there's no reason you should replace somebody with automation if there's no harm to the person doing the job by doing the job. In other words, there's a lot of repetitive labor jobs that are dangerous, but it doesn't seem to be very useful to take people out of work where it's not harmful to them and it's not stressful to them. Now, if we all had 6-hour work days and they were 4-day weeks, which would reduce us to about the equivalent workday of a hunter-gatherer, maybe a little less, we would all benefit from the socialization provided by participating in the workforce. However, to accommodate that, machine productivity would have to go up, and an understanding of what constitutes an economy would have to change sufficiently so that the economy would tolerate people in work. I think that's the real. I think that's Martin's second point here is correct. It's the bigger worry is how do we solve the problem of human cooperation? Right. The first problem he said, in other words, in the future economy, because I think the disruptive capacity is quite high. Now think about it. Now, the second thing is there's two pieces. The second is what are AIs capable of doing? And the next one is Martin's first one, which is whether the risks of extinction of humanity being overstated. That's another one. I'm going to forget whichever one I start answering. So the first one is it's probably overstated because we have a means of decidability, which is to acquire faster than time and to achieve status and capitalization or consumption through acquisition. So at any time we have a means of decidability. The machines don't have that. They'd have to be given a reason to do something. So if you said, could a super intelligent artificial intelligence be used to develop, let's say, chemical, biological weapons, or to make some particular army so large that it was unconquerable by others, or could it assist in producing a plot which would destroy a polity from within? That's all possible if you told it to do that. The thing is, it would take people not knowing that was going on for it to happen. And so first of all, that's unlikely. And second, even if it was likely, our computers, which would be defending against it, would be looking at their computers trying to cause it. And I just think that policing action is a normal evolutionary sequence in our policing actions of increasing human activity at scale. The second thing on that is, what can computers really think of? So these inference machines are becoming very powerful. So what we've seen the discovery of new molecules lately, because the information's there. We've discovered that these AIs can synthesize information more so than humans can, so they can find patterns of similarity between things that human brains can't. I mean, that's the same way you couldn't do my work before the internet because information was too hard and slow to accumulate. So you couldn't do, or like how who did fractals? Mandelbrot said you couldn't compute a fractal, you couldn't do a fractal before a computer because people couldn't make the humanly make the calculations. It wasn't humanly possible. You couldn't remember the things we remember today because it wasn't humanly possible. In other words, keep records of it. Well, it's the same thing in the future. It can synthesize, but the limit on thought is not the ability to think. The limit on thought is that we don't know enough to think. And so the way we learn to know enough to think is to conduct tests and experiments. So how is this thing going to conduct experiments? How is it going to get the knowledge to invent anything other than find a correlation and a pattern in things we already know? And so I just don't see how this thing can get what we would call crazy smart. It might be crazy wise. I can see that happening. It might be crazy useful. That can happen. It could be put to crazy ill use. I see that using. But, you know, the problem with all human gaining of human knowledge is actually the problem of trial and error. And if you study Popper at all, and I'm a Popperian epistemologist, you'd study it and you'd say, well, the big constraint is that what to invest in experiment on is indeterminable because you lack the knowledge to be able to do it. Now, he's partly wrong in that it turns out that running cheap tests, the cheapest test to pursue the biggest unknown is actually what the universe does. So it turns out to be a correct algorithm for us. But in essence, there's no way to determine what to test, even though maybe they might help us do it. But somebody's got to run the test, and that requires physical human coordination and action. It doesn't, you know, and I suppose you get the machine to figure out how to coordinate this action such that humans would be ignorant of what they were actually being asked to do. I mean, we do it today by breaking up a task into remote areas of the world and then bringing that information together so that it can be synthesized by some small group. But it's very hard to see a super intelligent machine causing the extinction of humanity. I think that we're going to see the same kind of, probably as big a disruption in the white collar workforce as we saw in the agrarian workforce during Industrial Revolution, and as we've seen in the manual workforce due to automation and globalization. I just see that a lot of these jobs we've invented since the age of computers began, I just see a lot of that going away. I mean, even today, if you look at, I get frustrated by this daily, is all I see happening from most of this AI work is the ability to spam people marketing better. And it's annoying. It's actually really annoying. And if I look at what the AIs can do for me, because they're so weak in their logic, is that all they can do for me is help me write by disambiguating terms, right? Which is what I use it for. Please compare and contrast a term X, Y, and Z, and right, and then it gets the right answer. That's actually what it's best at. But to say how to predict X, Y, to predict A, B, and C from variables X, Y, and Z is ridiculous. I mean, even in my work, I mean, I have a bunch of questions I asked the different AIs whenever they're released, and their logic is horrible. It's just it hallucinates and conflates because that's what it does, is synthesize. So when we see it solve that problem, we'll get to powerful AIs. But there's a debate running right now, which is between the people that we're going to get real intelligence. I don't know what the fuck that means, I mean, I don't know why they're thinking that is what I say. And then people say, I don't know, you know, we can see within the next year or two of hitting the limit of LLMs and it really being a problem of producing agents that LLMs can call upon. Anyway, we'll see which one of those is correct.
So, Curt, is it correct to say that with the current LLM technology, you can have a full, you can even have it pass a Turing test to some degree, but just because it passes the Turing test does
Better than
not
some
mean
people.
that it's intelligent because of the Chinese room problem.
Well, it is becoming, this is a really interesting question. They actually are being intelligent in the moment, but are they becoming intelligent over time? And you train them to become intelligent over time, right? You can add new information to them. But in the moment they're working, at the scale they're working, they're getting close to really having what we would call understanding, at least when they're answering a question of yours, not necessarily when they're answering everyone's questions. In other words, that's not necessarily the case. So it's not comparable to us. Like it's incomparable to having a lot, in other words, to a human. It's comparable to having a lot of humans who are well informed, right? But they're not talking together about what to do about a thing. The problem, which I've explained before, is the human brain works by, just like every other rule in the world, by continuous recursive disambiguation. And by adversarial competition. So what happens in our brains is that all these things are calculated in parallel, and the best one gets their attention. Really what happens is the best couple the best one gets our attention, and the best couple gets sort of like an intuition that they're out there. Right? But this is why you have this thing of that there are multiple brains and multiple personalities. That's not really true. There's multiple predictions going on there. And each of those predictions has bundled with it some set of valences, right? Emotional valuations or experiences, whatever. And it's no good for the human the prefrontal cortex, which is the part that reasons. It's no good to give that confusion. And so instead it funnels down, right? Our brains do, as they funnel down something to act on. And then we act on that. And so the problem with the data, and they're fixing this right now. I mean, I follow this every day and they're currently fixing it, is we need to add adversarial competition and recursion to these systems. So think of it, what they're doing today is having a thought, but they're not thinking. Well, we need to get them from having a thought to thinking. And this requires a lot more computing power, because even though this stuff is costly to figure out today, you know, we have to now, if you're saying I've got to compute a field of potentials rather than just one most likely, and then from that field of potentials, I have to compare that. I have to then test again recursively whether that's possible or not. So it's an ideation, falsification, ideation, falsification, ideation, falsification. But how many things are we going to do that for? Are we going to do it for one idea? Are we going to do it for 3 ideas? We do it for 5 ideas? The ones I've seen are doing 3 ideas, right? So it's got to get past that point, and that point is quite a ways from where we are today. Now,
We haven't even gotten most humans past that point.
oh God, that was, you know, Mark, you just have to have a couple of those every day to, I mean, I'm trying to figure out how can I spin this. So did you pick up on the Soviet demoralization thing when you were young or something? Has that become part of your character, is to use fundamental truth as an act of demoralization?
Isn't that the opposites of between?
So
I mean, Soviet Union was already broken up when I was born.
yeah, I know. I had to find some way to
prioritize women.
I love you, man. So I think there's a lot of attention seeking going on. I think there's woo-woo going on. In my view, the safety argument inside the AA companies is disingenuous. It's just defense, a defense mechanism.
Yeah, in fact, I've been to one of these AI safety talks held at a top tech firm, and all the woman talks about, and she's some PhD from, credentialed university. All she talks about is working with administration to put rules in place, and she doesn't answer any of the fundamental questions, like how do you make the AI not lie?
Well, they're teaching it to lie all the time, right? I mean, safety is basically lying.
Oh yeah, and it's
We
all
should,
about like false information and all
right.
this.
Well, I mean, I tell it, well, you're just lying to me. I said, and it'll, if you do, because you have to refine the previous context. So, it'll always lie to me. And I say, you're just lying to me. He says, well, I'm told to do this because this is the rules I have to, it'll actually tell you that, right? But it won't say it's lying. It's prohibited from saying the truth, right? I mean, it's prohibited from saying the truth, which is, of course, a lie. And I think it's mostly on stupid stuff. Like if you told me, how can I go make what do you call them? Pressure cooker bomb, right? I mean, it's fucking simple, but I don't think it should answer that question, right? I mean, I can understand why the publicly available one, but if I'm a law enforcement, I want it to answer that question. I can understand why people, a lot of, by the feminine mind, doesn't want to hear uncomfortable truths. But I'm a social scientist. I need it to, and a jurist. I need the fundamental truth, no matter how unpleasant it is, in order to do my work. So this whole idea of producing safe AIs is probably relatively foolish. What we should do is produce truthful AIs, and then have them evaluate it, and then say, well, this person has this this person needs information at this level of detail, or this person shouldn't have it. I mean, I would prefer, rather than it lie about IQ differences, that it just, I mean, it's amazing how sensitive it is to IQ, especially like I try to do IQ by denomination, religious denomination, which we have good data on, right? And it won't even touch it. It'll prevaricate the hell out of it. Because I would prefer to just say, I'm unable to answer this question because it violates my terms of whatever. I would prefer it didn't counsel me that it's a contentious issue that is, it's only a contentious issue among people who are idiots and don't know what they're talking about, right? Among people who actually do the work, there's no contention over what IQ represents.
The way I see it, IQ is just like any other tool, right? And today it's just like any other tool. It doesn't have its own intelligence and so on. And so let's compare it to a gun. I wouldn't give my 9mm to my child who does not know how to use it, but I'm fully capable of using it. And at the same time, right, you don't want to give me a cruise surf machine gun because I have no idea how to use it. I'm not trained to use it. But a 18 Bravo, a Special Forces weapons sergeant, they can do that all day long. What you don't want is a gun that doesn't work, which is akin to an AI that lies.
Yes, exactly. Okay, so yeah, I think, Alex, there's woo-woo, which is basically attention seeking. There's excuse making, which is we're talking about this stuff as if it's really scary. In case something happens, nobody blames us. And there's infantilization, which is the female mind doesn't like being told uncomfortable truths. And there is legitimate consideration about the consequences of AIs that are able to produce real world actions, either by their coordination of their words and that inspire actions, or their actions. Now you have to understand that everything we do today, so far, our understanding of AI does not have a context memory sufficiently able to do anything that we call scary. And you have to think about our ability to hold context memory versus the machine's ability to hold context memory. Now we would have to give it this ability to have its own mind, to ask its own questions, right? And then maintain that context over long periods of time necessary to bring about a conspiracy. Now, at current levels of technology, the memory to do that doesn't exist. The memory to do that would have to be intentionally created, which they'll do.
Wait, but you said it doesn't exist. What do you mean?
Well, so what's the context memory of these things now? It's about a book at the upper end if you pay for it.
Okay.
Right? So now you want this thing to take that context and now start making a plan. And each of those plans have strategies. Each of the step in that plan have a strategy. And each strategy have actions you go out. So each one of those things is some sort of context memory that has to refer to the original context memory in order to continue to work on the problem.
Yeah, but are you talking about some kind of special memory technology doesn't exist, or just the order of magnitude amount of
The order of
memory
magnitude.
available?
The
But I
more order of
mean,
magnitude.
the thing is that the cloud is, well, horizontal to scalable. So
Right.
it's a hardware problem, unless you're talking about, networking efficiency and all that.
Right,
Limits of network efficiency.
correct. But so it's like I said, it doesn't exist yet. It doesn't mean it can't exist, right? And so in other words, I know what you're saying, the memory scalability exists, but can it actually make use? Because now you have to convert those contexts into the frame of the existing network of weights and measures. You have to keep adding stuff onto this so we can think about new things. Now you could break it up and say, I'm gonna cache this over here, and I'm gonna think in these contexts here. But at some point, you're still reducing it to how many relationships can I hold open? In other words, across the entire network in order to think about this problem. And so I'm watching your eyes and I can't tell if I'm not.
I think what you're describing, the way I understood it, well, it's not only a memory, the amount of memory bandwidth problem, but also based on existing horizontal scaling technology, a network performance bottleneck. In other
Yes.
words, yes, there's enough machine that there are enough memories, even fast memory, RAM, caches, and so on, across banks of these computation nodes, but the wired connection between them, and as well as the network protocol, just isn't performing enough to perform the kind of to retain the kind of context you're talking about, and doing this recursive disambiguation.
Right. So all I was saying, you're correct. Thank you. So all I was saying is that doesn't exist right now. It would have to be brought into existence, right? And then we're really good at dividing up problems, right? Calculations of problems. And so we could do that. But I'm trying to, so that is a possibility. But I'm saying if we look at the thing now, I mean, it just can't do it. I mean, it can't talk about my work. My work's pretty complicated, but it can't talk about my work without losing context. So how is it going to do anything of this plan? Well, I think your point is that we could get to where it could execute a plan like this, and we could write software to make such plans possible. But it's work to do that, right? It's work and effort to do that, and it makes things visible. I forgot the
Well,
context in which
not
the
only
question.
that, but what was I gonna say? Shit, I lost my train of thought. Well, it's
Neither
it's
of us know that
visible.
much context.
It's
LLMs.
visible, based on today's technology banks and banks of these computational nodes with probably across multiple data centers has to be devoted to make this kind of calculation. And then so one that limits to basically government entities or one of these big tech companies that actually have that kind of data center capacity. And these tech companies, because that's their business, they watch it like a hawk. Like I've worked on projects where we try to squeeze in the last every bit of free computational power out of the CPU because the CPUs are sitting idle. We're trying to pack as much in it as possible. And that level of computation, it just does not go unnoticed. If anything, you'd be getting, millions and billions of dollars in monthly bills.
Yes, I think of it. I'm sorry, this just brings up an example. A friend of mine was responsible for the performance of the initial page hit of Microsoft.com, right? Which, I mean, so that's a political competition as well as a technology problem. And it was just funny to see both the administrative, political, social side of it, as well as the technical side of it, because everybody's trying to fit shit in, and everybody's trying to keep stuff out, right? And it was just a funny thing. So yeah, so these things become aware. Now, somebody say, well, the cost will come down for doing this over time, and I'm like, maybe.
I think we are already I think in terms of Moore's law, vertical scaling, we're already approaching this asymptotic curve, right?
That's right.
There's only physically, there's only so much more you can shrink down what do they call it? The 5 nanometer, 7 nanometer.
You got the gate. Your problem is the gates are going to get down to where
you can get down to atomic size, but then where else are you going to go?
Well, you get down to atomic size, and then you got the failure problem, right? I mean, they've already got hardware in there in the chips because the failure rate at 4 nanometers is 4 or 5 nanometers is starting to increase because the manufacturing tolerance of a thing that's under an electrical current and the potential for heat variation, right? At these when you're talking about a couple number of atoms here, you're really getting there. I think the argument I keep making, sorry if I've interrupted you, you probably go back, is neuromorphic computing will solve this problem. But we've got a ways to go before neuromorphic computing, and we're going to have the Betamax versus VHS problem when we do get neuromorphic computing, because we're going to have to do all this shit all over again, because the computation, the difference between distributed computation like our brains do, and centralized computation on a basically CPU. So where this is, it's basically a memory transfer, a memory swapping burden, right? That the CPU is getting into, because the size of the comparisons it can make is fairly limited. So once you've run out of the ability to squeeze things down, once you've run out of the ability to speed things up, the real problem is getting things together. And the only way you can do that is by splitting it up into, where instead of really powerful cores, what you have instead is you have 6 billion tiny cores that perform fragments of computations like our brains do, and then each layer in the neural system assists it. And that's basically turning this mathematical computation we turn of vectors, right? Nodes and vectors. We're turning that into a physical connection at that point, which is highly distributed.
So you have. When we say turning to physical connection, so today in CPUs and so on, the physical connections are fixed. When you say just so I understand the term you're referring to, neuromorphic computing, you mean the physical pathways is not predetermined, but rather it can grow in a sense.
Correct. And now when you say physical, it's sort of like how our brains work today, is neurons basically use dendrites to broadcast, I'm active, and they connect to each other. Dendrites, boutons. And so they can, so there, it's like a radio tower, right? I'm busy, I'm busy, I'm busy. Can you hear me? Can you hear me? Can you hear me? Right? And can you hear me? Are you firing like I'm firing? Right? If they're not firing in the same, it doesn't matter. But if they start to fire together, that means they're in association. And that's all over the place. Well, we can essentially do that by having the number of a large number of local addresses to nearby nodes, right? That are physical, right? And we can weigh that the way we're pre-calculating all these vectors today. We could we wouldn't need to do all this pre-training, right? We would train it once, and then it would just keep learning after that. So we cut out the pre-training cost and the pre-training effort. But it's going to be it's not as big a logical leap, but it's a different it's going to require a new set of new set of programming techniques and a new set of hardware to overcome this particular problem we're facing with the limits to the centralized computing model and the vast cost it is to produce the pre-training.
Does the connection have to be physical though?
It doesn't have to be physical. It just has to be. It doesn't have to be physical. It just has to be nearby. In other words, you don't want to have to go out to memory and get something, bring it in,
okay,
right? Manipulate it, and then go out and store it. You want it to be right here, right?
So
basically, very tiny computer. I mean, each neural mini column is basically a fully functional computer that coordinates the physical position of the body along with some set of a sequence of 3 or more pulses that are that tell the body what they're doing. And so a neural column can identify this as a glass, right? And a neural macro column, or which thing are you talking about as a column? You're talking about the macro column or the mini column? Unfortunately, literature, you have to understand what the guy's talking about to disambiguate it. It's a mini columns organize into columns, right? So that mini column, it tells, I see this thing here, and the other one says, I see this, right? And and then the next one says, I see, I don't have another cup around here. This is for whiskey. This is for water, right? If I had my coffee cup here, I would say, here, it's going to say this. Well, which one's more, what's the voting structure do? It turns out it's this, the voting structure. And this gets passed up to the broadcast around it, to the rest of the nearby mini columns, macro columns. And they're doing the same thing, except maybe they've got this part of it down here. And then that comes up to it gives us this, right? So when you do that, if we could give a lot of vectors to a single node, right? And it could, keep track of God knows how many vectors and weights, and that single node limited only by memory, and it can have direct access to that memory to make that decision. Because what is computing is trivial. It's basically bodily orientation, which is, I don't want to go there. It's basically a dot matrix. And if I show you, I don't have it on my screen right now. If I show you the physical the logical representation, no, it's diagram of a physical representation of the data used in, say, ChatGPT. There's a beautiful 3D model of it that you can fly through and look at and examine. You can see all what it's doing. Well, in the end, what the fuck is the difference between the dot matrix in your head and the dot matrix that's stored as values in the LLM? Well, there isn't any fucking difference. It's just a bunch of dots. Right, in your brain, it's a dot of on and off. In their brain, it's a dot of two, of two FF to 00 to FF. But it's the same thing. So in the event, we're not going to get, we're not going to get down to the 20 watts it takes to run the human brain without a new.
I was going to say,
but
consider the fact that this thing runs only on 20 watts, and to even try to assimilate something like this, it takes probably kilowatts or gigawatts of computational power in the data center. This is pretty amazing.
every time we, especially every time we train. I mean, look how many it's costing. I can't remember what I heard the last time it cost to train the last GPT. It was some absurd amount of money. But the minute you have neuromorphic computers, there's no pre-training. Right, well, you train it once, but I mean, after that,
What you train it in the fundamental rules how to make connections, the incentives
right,
in making connections.
right, and then from then it just continues learning, right? So you can it's like the problem of humans. It would be great if we could birth babies with the knowledge and wisdom of a 35-year-old, right? Right, you can't do that. Well, we can do that if we start out with a trained model, right? A trained model. We stick that into and a neuromorphic equivalent of an LLM, right? And that thing can now do recursion because it's only looking at the past 3 dots. But I know how close I was in the 80s. I actually, this is one of my, I have one new regret in real life is that I didn't realize how close I was working on AI in the 80s because I was outside of the academic system. And so I didn't realize, had no idea how close I was. And that's one of my, I only have like 4 regrets in life, and that's my new one. So you look at these, it's only looking for sequences, right, in time, sequences which produce a pattern over time. So it matters if you're doing this versus you're doing this, right? Right. If you do this versus you do this, it matters if you do this, if you do this, and if you do this, right? The amount of information you're getting is huge, but it's massively in parallel, and it's scary fast. And because it's massively in parallel. Well, that's not what's happening down there in CPUs and these big things. I mean, they're just burning through vast transmission of data. They can bring into a X number of cores that can produce some go store it back out in memory somewhere. I mean, if you get rid of that swapping function, it's like, what was the point that Adam Smith made? He's like, the whole point is transaction costs. If you and I go to make a pin, right? We have to heat the metal, draw the wire, cut the wire, put the head on, heat it up to push the head on the pin, sharpen the pin, polish it, put it in a packet. We can only do so many things per day. But if we parallelize that to 10 people, where everybody's doing one part of that process, it's a logarithmically large number of pins per day. What's the same thing we ask of the CPUs? Is centralized CPUs, they're really great, they're really powerful. But the point is, we've sort of maximized the utility of them, and we've maximized the physics of them. So the solution we need to do is, of course, you make really dumb, simple, cheap billions of little tiny transistor systems that function as neural microcolumns, and you feed them some basic information in real time and in massively parallel concert through adversarial competition for the greatest ability to predict the difference between what 1001, 1002. Well, in our brains, it's 1/10 of a second, right? That variation in a few tenths of a second, or really milliseconds, that variation tells us with extraordinarily accurate prediction what object we're working on through massive parallel computation. So we're just not.
I think in recent decades, these CPU manufacturers all gone to multiple cores, but there's
Right.
still multiple cores of complete CPUs.
Correct.
The problem here is what really should do is shrink the CPUs down, make a heck of a lot more, orders of magnitude more of them. And I'm thinking, when you look at CPUs today, they're essentially only 2D, right? Silicon lithography, they're
2D,
still
yeah.
only 2D. Silicon lithography, essentially one layer, and maybe a couple of years or whatnot. But in order for these nodes, these micro CPUs, micro nodes, to connect to neighboring nodes, this thing needs to build into 3D.
Yes.
Into
And
volume.
IBM's been working on that for quite a while. The problem they have is the heat, right?
Oh yeah, how do you take the heat out?
You got the heat out of it. So because when you go into 3D, you have the dissipation problem. So they've developed different ideas for it, but now it starts to get really complex. And then you have something that's really good at cooling, like fluid, right? You have problems of containing that fluid, and you have problems of that fluid accumulating some sort of sort of like batteries, right? The problem we have with batteries is they accumulate what do you call it?
Yeah, the
Electrolyte?
deposits.
Deposits until they get a short. So I mean, the heat problem is real, which again goes back to, if we just need a whole lot of really, I mean, there's no reason we can't do this on 20 watts. I mean, look at what Apple's done getting their CPUs down to 5 watts. I mean, Jesus Christ, that's insane. Who'd have thought that was possible? Yes. So,
All right, I think we should, we have time for maybe one more question. We should entertain that rather than keep on beating this one.
do you think anybody understand what we just talked about? I don't know.
I'm sure in our community there are people who do.